Dear board members, thank you for the opportunity to share our proposal. Today, let's begin with a simple question. What do furnaces and pollution have in common? Quite a lot. Industrial furnaces, especially in metal production, release a lot of harmful gases and particles that damage both the environment and our health. Most furnace hoods today are made of stainless steel. It's strong and heat resistant, but not very effective at capturing pollution. That's exactly we set up to do. Find better materials for furnace hoods, ones that can handle heat and also reduce pollution. We tested four materials. The first one, regular stainless steel as our baseline. The second one, CNTS, lightweight and strong. The third one, PTFE filters, greater at capturing particles. And the last one, ceramic coatings, the material like you see in space technology. Our functional focus: capture, resist, and survive. To find out what materials work best, we follow Huang et al. 2015's guidance, building a lab setup that simulated real furnace conditions, heating up to 1000 degrees Celsius, adding corrosive gases, and regulating airflow. We tested the material's heat and corrosion resistance, and most importantly, their ability to capture pollution such as gas and dust. To do this, we use tools such as SEM, life cycle assessment, CFD modeling, and so on. Thanks to Wang et al. 2019, Sabedra et al. 2020, we find CTMs 60% stronger than stainless steel, lighter and more heat stable, and PTFE filters remove nearly 90% of PM2.5 without using energy. And ceramic coatings like titanium dioxide may help reduce harmful gases like nitrogen oxides under heat. On the other hand, SS316 performed the worst in capturing pollutants. In short, CTNs and PTFE outperform traditional materials in strength and emission control. Our work fills a key research gap linking emissions control theory to material science. We tested materials under realistic furnace conditions, not just in theory. We also show how material microstructure affects real-world environmental performance. Through CFD modeling, we confirmed how gases interact with these materials during operation. In conclusion, advanced materials like CNTS and PTFE are more than just upgrades. They're a leap forward in making furnace systems cleaner and safer. Our research provides a solid scientific method to guide material choices for next generation furnace hoods. And more importantly, this helps industries move towards sustainability and carbon reduction, which is essential for a greener future. We've shown what's possible. Now we're ready for your questions. Thank you.